Hi everyone, thanks for showing up to my talk titled How to Learn and Teach Hacking. It's not a technical talk. It's the end of the conference, maybe you're already tired. But it's not going to be too complex. So the talk has 3 segments. First of all, I'm going to explain what hacking actually means. Then we're going to talk about how one might learn it, and then how to teach it. But first things first. If you can't hear me, say something or raise your hand. I really don't like this room because you always have first row feeling. But okay, I'm going to stand closer to here. I'm a security researcher. I'm also trying to do my PhD. I love CTFs. What these are, I'm going to explain in a little bit. And I'm a trainer at ITsec.rocks. That's a company that does information security trainings from a defense perspective. Well, if you see this picture first of all, I want to say that the organizers cropped this picture because you might be wondering what the hell I'm doing. I mean, I am German after all, but of course I'm holding up a zucchini. As a cyber zucchini. It's our team's mascot. And what team am I talking about? Well, Konstantin, that's the guy with the beard, and me, we founded at our university a club for hacking stuff. We were a bit bored, we were missing enough practical exercises at our university, so we started competing in online hacking competitions, and we invested a lot of time in them. We really, really liked them. Our team grew over time. So we went to DEF CON CTF, which is the DEF CON hacking competition. Here some people look tired because those competitions, finals usually last 24 hours, so you don't sleep for a while. And our team grew and grew. And at our university we now have a lot of people that are interested in information security and hacking. The nice gentleman here is the dean. He's not part of the team. Okay. So what do we do in this club? We just meet once a week. We hack together. We started at these competitions, but we also hack real stuff. A nearby mall, for example. And more interestingly, and that's why I'm having this long introduction, is we teach. One professor of our university actually stumbled across write-ups. We published write-ups on our blog about interesting stuff we did. She said, that's actually quite interesting what you're doing. Why don't you teach a course at university? Full course, 6 CTS credits. That's really uncommon because we were still students at that university. But that actually forced us to think about what we're doing. We had to think about what hacking actually is. And if you can even teach it. So that's what this presentation is gonna be about. Okay, so of course you look up the stuff on Wikipedia first. What does Wikipedia say? A computer hacker is a skilled computer expert that uses technical knowledge to overcome a problem. But synonymously, nowadays, when you say hacker, you usually mean a security hacker. That's somebody who uses bugs or exploits to break into a system. As we'll see, these two are equivalent. A security hacker does the exact same thing. It's also just a skilled computer expert that tries to overcome a problem, just the problem looks different. So when I say hacker in this talk, I'm always talking about security hacker. Okay. Now, first lesson at the university, there's a weird course called hacking. I told my students the hacker makes an application dance, which sounds really stupid, but it kind of captures the idea. If we look at this code, it's in the beginning of the lecture we always had very small code snippets that they had to break, boiled down code. So this code, if you would find it in a bigger real application, you would say, okay, the programmer intended to get some user input called PW, hash this user input using MD5, and then compare it to a hash. hex value of a hash. But that's not at all what this code does. If you're familiar with the topic, maybe you'll see that this string starts with a 0e. So PHP thinks this is, okay, looks like a number, looks like a floating point number, a 0 with an exponent. So it just implicitly casts it to a 0. So essentially, in order to reach this code path and to receive the flag, we just need to find a hash, a value that hashed starts with 0e. And what PHP does, it compares 0 to 0, which is of course true. What does that have to do with dancing? Well, the programmer never intended this. The programmer never implemented purposely a comparison of two integers. And that's what the hacker does. The hacker always uses the difference between what the programmer thinks he does and what he actually does. Another example. This is a Python code from a real web application. There's a function that takes a SVG file, it's a vector graphic, and converts it to a rendered PNG file. Sorry if I screw up the microphone. So, I don't know if anybody sees the bug here in the code. Well, there's no bug in the code. Well, there's bug in the code, but it's not in the code, because it's in a third-party library. We all know how application development works nowadays. I do a pip install, I do a git clone of a library that I like, and then I'm going to use it. Abstraction is good from that point of perspective. From security perspective, it's really bad. This library, internally, because vector graphics are defined in XML structure, uses LXML, it's a Python package, which is a wrapper for libxml, but per default, LXML enables external entities. So with this code, you can extract all files from the server. Again, you're doing something that the application developer never intended. You wrote a program to transform an SVG to a PNG. Yeah, so the problem is that he uses a library that uses a library that uses a library that has a bad default value for allowing external entities. If you're interested in it, Google AppSecEU. A bit more scientific, and that's my last example. This is binary exploitation. This is assembly instructions, and they jump. There's a comparison. If it's false, it jumps here. If it's true, it jumps here. And what you as a hacker do is you include another edge. You jump somewhere, you alter the state in a way that the programmer never intended. That is not obviously in the program. So, what does a hacker need? Well, very good basic understanding of computer science, or if he wants to specialize in something like web, then he needs to be good in that. But on some level it's all related, so a general understanding of computer science is very good, I think. He needs an eye for attack vectors. After a while you kind of get an idea where usually bugs exist, and where bugs exist, vulnerabilities exist. You need creativity, very important, and a very high threshold for frustration. Because very often you will look at code for hours or days and then might not find anything. From a teacher's perspective, the first two you can teach somewhat. The last two is up to the individual person. You can't teach somebody to be creative. That's something the person has to come up with themselves, exactly with the frustration threshold. So you shouldn't waste time on the last two parts, because you can't do anything about it as a teacher. Okay. Now how to learn it? Well, you learn it pretty much the same as most other difficult topics. Read a lot. There are very good write-ups about security vulnerability exploits, papers, books, and advisories. Gonna make a statement that's not gonna make me popular, probably, but I really don't like most of the information security books. Like, I think most security books actually really suck. And what I encourage you to do is get a normal computer science book, maybe about foundations. Example, Modern Operating Systems by Tannenbaum, and learn about how a file system works. And once you understood exactly how it works, don't think like a developer, how could I make it better? Think like a hacker, how could I break it? Yeah. So, for reading books, I recommend reading normal computer science books, not security books. There are very good talks, for example, at media.ccc.de, that's a media platform from the Chaos Computer Club. Sometimes you find DEF CON talks online. And for practice, which is really important because you need to get your hands dirty, otherwise you're not going to become successful, is my very big recommendation: play CTFs. Okay. Who knows what a CTF is? Oh. Wow, okay. Well, it's around half of the room. That's nice. So I'm gonna go over it briefly because I don't want to lose anyone. CTF is a very simple game. These kids are playing it. There are multiple teams. If you steal the flag from a team, you get a point. If somebody steals your flag, you lose a point. Here, my teammate, Gaozu, is playing the exact same game, just the hacker variant. It's an attack-defense CTF at DEF CON. Yeah. So, how does the CTF work? Well, in the beginning there's a service usually. We're at OWASP, so let's assume it's a web service. It can also be an encrypted file to download or TCP port, whatever. And within this service, oh, there's my mouse. Has it been there the whole time? Oh, sorry. Within this service, there's a flag buried. Most likely in the file system of the server, but it can also be somewhere inside that service, on an admin page or something. And your goal as participant is to hack the service, for example, get remote code execution on the server, and then extract this flag. Once you have this flag, you submit it to the organizers and you get points for it. In an attack defense CTF, other people host these services, and in a Jeopardy one, it's hosted centrally by the organizers. Usually, there is a prepared vulnerability in that service, and you need to find it. Very often, there are more vulnerabilities in those services, so there are multiple possible solutions. And now it's even a trend, because these competitions have come really far to have a zero-day category with actual services, with not prepared weaknesses. Yeah. It's pretty crazy. These things are getting more and more difficult, but also prize monies have risen to an insane level. Okay. Oh, it was a bit abstract. Look at an example of a CTF task from 3 weeks ago or so from the Tokyo Western CTF. That's a CTF team from Japan. It was a PHP service called PHP Note, and it was a note storage service. You could just create an account, create notes, and save them, access them later. You were given the source code. It was quite obvious that the goal was to access the notes of the admin account, because there would be the flag. We poked in the service. We spent a lot of time on it. I invested like 12 hours, I think, in the challenge. And the code base was pretty big, but at some point you find out, okay, the cookie that is delivered has a flag if you're admin or not, but you can't just change the cookie because the cookie is MAC'd. And in order to create your own MAC, you need to get this secret, which is a global secret, but it's stored server-side, and it's stored in your session. So how do we access the secret? which is just in the session. We can't, from client side, access it. And we looked at this source code for, as I said, very, very long. How did I solve it in the end? I didn't. As I said, these things are pretty difficult and I didn't manage. We found some ways to fiddle with the server, but we didn't manage to extract the secret. It's the first lesson in CDFs. These things are, the good ones are really hard, and you will probably fail a lot. But afterwards, I read a write-up from a team that solved it, and the actual solution I want to present because it shows why, in my opinion, CDFs are a really good way to learn hacking. Well, the server was running on Windows. We saw that it was an IIS. We were trying some stuff. It was the latest Windows version, latest IIS version, latest PHP version. We didn't think it was important, so we didn't investigate further because we didn't find anything while poking. We were staring at the PHP code. What we did know is the session files in PHP are stored on hard drive. Usually this file is called session underline and then your PHP session ID that you also see in the cookie sometimes or in the URL. And what we didn't know, what makes sense, is Windows Defender was installed on this web server that was running Windows. And what I personally didn't know, Windows Defender just blindly executes everything. It just doesn't matter if it finds an ARM binary, x86, JavaScript, doesn't matter, it executes it. Because it wants to find out if it's malicious. It runs this in a sandbox to be safe, unless you can escape the sandbox, but that's another topic. So how can you solve this challenge? How can you access a secret that's stored on the server in the session file? Well, Windows Defender is pretty strict. If it finds a malicious code, it just deletes it and it's gone. So if we manage to inject malicious code in our session, the session file will be deleted, so the session will be dead. We can't log in. We can inject malicious code because our username is also stored in the session, which makes sense. And we can register and can choose our own username. So, as I said, this is a write-up from another team called SASEC. It's another good German team from the Saarland. And what they did is really clever. They created a username that's JavaScript code. Yeah. That's going to be written to the session file. And it's going to be written in the beginning of the session file. And the secret is stored afterwards. So this is JavaScript. And here they open a body tag. So everything that comes afterwards in the session file is considered the body. What do they do then? Well, they create a string, new coin. Then they check what's the next character. What's the first character of the body? So what comes next in the session file? And if this first character matches T, put the character H here, and then the string that's evaluated, called mel, will say new coinhive.user. And what happens is Windows Defender just deletes the session file. Because it says, okay, they're trying to mine coins on this machine, this is evil, I'm going to delete the file. And that's quite clever because we built ourselves an oracle. Every time, if and only if, this character matches the next character in the session file, Windows Defender will delete the session and we can't log in. So, via a side channel, we're able to extract the full session file and therefore the secret and make it ourselves. And why did I like this challenge, even though I didn't solve it? Well, as with every good CTF challenge, and there are a lot, people invest a lot of time in creating these challenges, you have to think outside the box. We were so sure that the bug is somewhere in the PHP code, we were digging in it all along and we ignored the surrounding environment, which you should never do. And in the end, it was not so difficult, but you need to think outside the box and also take the environment into consideration. So, was that time wasted? Those 12 hours spent on this challenge? You have to decide. I say definitely not a minute, because during those 12 hours we were learning super much about PHP internals, because we were looking for bugs everywhere. We were looking up the latest exploits for IIS. We were seeing where IIS might have problems, because IIS is also prone to side channel stuff. And I learned super much in those 12 hours. In the end, I didn't solve it. It was bad because we didn't qualify for the finals, but it was still well invested time. So, if you want to learn how to hack, security hacking, what I suggest is really read a lot and play those CTFs. The usual workflow is you solve a challenge, that gives you points, you move up in the scoreboard. Usually top 10 are invited for finals, trip paid, and everything. And then you write a write-up so other people can read what you did. Because there are always different kinds of solutions. There's never one correct solution, which is nice. And then you repeat that step every weekend. Or as much as you want, but one thing I mentioned is that in the beginning it's not going to look like that. That's with every new CTF team. In the beginning it's going to look like that. You're not going to solve anything, probably. You're going to stare at code for 24 hours and maybe get some points, but not a lot. You're going to be really, really down the scoreboard and lose the CTF, but afterwards, definitely go and read write-ups. This combination, spend a lot of time investigating stuff yourself, and then read up-to-date write-ups from other people, is extremely effective in learning. Okay, so here's the first step program to learn how to hack. First, very important, find a group. Hacking alone is really not fun, at least in my opinion. When you're working on a CTF, you're usually working individually, but you're in the same room. You can talk to other people about what you're working on. They bring in their ideas, is very helpful, especially if you're playing competitively. I would encourage you to find real-life people. There are also teams that just meet online. If you want one of those teams, they're called Open to All, for example, or SecuriSec. And they're just, literally open to all. You can just join their Slack and then work with people online. For me, it's a lot more helpful with real people around. So maybe find a hackerspace nearby and see if they have a CTF team. If not, found one. And then do those steps and repeat over and over. If you want to get started with CTFs, there's a platform called ctftime.org, which lists all the CTFs. As I said, this community used to be pretty small. There were mainly university students challenging each other. Now there's, in the CTF season, which is in the winter, probably 2 CTFs each weekend. You can even choose which one you want to play. There are a lot of beginner-friendly ones, but there are also very, very difficult ones. And mind the rating. CTF Time has a rating for the CTFs. And that's important because that means in previous times, in previous years, these CTFs have proven to be good. So there's a high chance that they're still good. If they don't have a rating yet, it's also possible that somebody hosts them who is not good. And you shouldn't invest your time in bad CTFs. That's boring. So play CTFs with a high rating. There's also a team rating. Right now we're not in the top 10 anymore, but we're on 1 in Germany, and our goal is to be in the top 10 again at the end of the year. So if you want to play competitive, this is a really big encouragement if you see other teams and you want to participate. Another thing, probably everybody says that about this community, but for me the CTF community is awesome. I have only met really, really great people at finals or also at congresses, and it's really, really awesome community in my opinion. And everybody's welcome, also if you're a beginner or pro, doesn't matter. Okay, so essentially for learning, read a lot, play CTFs, that's my advice. Now about teaching, because I was motivated to do this talk because we had this course about hacking, and we had to think about it a lot. And I would encourage you to maybe, if you have the time and you're willing to, start a course on your own, maybe in your hackerspace or at your, in your university or wherever at work. But you should keep a few principles in mind. Because the CTF sphere is pretty popular. A lot of companies are hosting CTFs now. A good CTF, for example, is the Google CTF. Also relatively large prize money. But if you want to go for prize money, it's probably better to do bug bounties and that kind of stuff. I would say play CTFs for fun, not for money. Facebook hosts a CTF now, but there are also a lot of smaller companies that also want to host CTFs, and sometimes they do it really wrong. Or some people even want to use CTFs for training internally, and they're not doing it correctly, and then nobody profits from it. So I'm going to give you a little bit of advice, what we learned and what we did and what the students really, really liked. The magic word is problem-based learning. So what is problem-based learning? Well, PBL is very simple. The basic idea is that the starting point for learning is a puzzle that the participant wants to solve. Doesn't have to solve, but wants to. It has to be combined with a traditional lecture, so you have to teach them stuff first and then use PBL. PBL alone, research has shown, is not effective. You have to combine it. What is PBL used for? Interestingly, mostly in medicine curricula, and it's very good for turning theoretical knowledge into applicable skills. So the problem with medicine students was they were learning a lot of stuff at university, had to learn a lot of stuff by heart. Then they entered, started in a hospital, and they couldn't do much because they never learned to approach a problem all by themselves. And that's what you tackle with PBL. You throw students into the cold water, and they learn how to teach themselves things and how to use their fragmented knowledge, how to combine it, how to connect the dots, and then solve complex problems. There are 4 rules to PBL that you should stick to. First of all, the problem that you're serving your students has to be authentic. Gonna say more about that in a bit. Then the students should work in small groups. You do tutoring, not teaching, during the PBL phase. That means you don't help your students at all, which is difficult because sometimes you want to help them, but if you help them, you're actually not helping them because you ruin the element of, I have to deal with it by myself, which is the most important element. I have to come up with a solution. And first I have to find the problem. Yeah. Again, with the medicine students, if you start in a hospital, nobody's going to tell you, okay, this man has this illness and you need to prescribe him this medicine. First, the medical staff has to find out what the problem is, and then they have to find a solution. So don't help your students during the PBL phase. And individual knowledge gain just means that individual students go on Google, go on the internet, get a book, whatever, and start learning by themselves. The practical thing is the last 3 things really come in naturally in a CTF. If you use CTFs in your lecture, you don't have to worry about those. But the first problem, the first point, authentic problem, doesn't come natural. It's actually quite hard to write authentic problems. Because for a hacker, an authentic problem is a real software system that you have to develop so you can hack it. and that's work. But in general, if you have authentic problems, realistic problems, CDFs are really a perfect way to teach hacking. So, I said a lot of people want to use CDFs for teaching, but then don't really stick to PBL. And PBL is what makes CDFs such an effective learning tool, in my opinion. So, what to avoid? Explanatory texts. Very important. As I said, if you explain the student the problem here in this application is it has an SQL injection in the file info.php, exploited. The student's not gonna have to come up with what the problem is itself. And a large part of hacking is finding the vulnerability, not only using it. So there should be absolutely no explanatory text. As a PBL basic rule, there should be no context. You're just thrown into the problem. There shouldn't be a mandatory correct solution. You see this especially in educational CTFs. Do that with this, or do exploit this as described here. That's bad, because in that second, the student doesn't have the feeling he does something, he doesn't have the feeling he's working realistically, and then he's not motivated anymore, and then his brain phases out. Don't help the students during the PBL phase. During the lecture phase, of course, if somebody has a question, you answer your question, but during PBL, they're on their own. And avoid guessing challenges. If there's a part in your challenge which has to be guessed, then it's a bad challenge. Okay. To make it a bit more practical, here are two examples for tasks, both from cryptography perspective. So you get an RSA encrypted secret. You want the secret. That's the point. You get a modulus and two exponents that lead to the same ciphertext. And then, this was an actual task, that's why I presented. Recover the plaintext using the algebraic property. Blah, blah, blah. And that's really bad because, first of all, this is not realistic because look at the modulus. It's 2.5 bytes. I can brute force that in seconds. Not even a second. So the obvious solution here is to just brute force the modulus and have the plaintext, and I'm done. But this explanatory text doesn't allow that. It says you have to use a specific property. In that second, the student phases out because his brain says, okay, this is not relevant. I would tackle this problem completely differently. I would have a much nicer solution, but I'm not allowed to use it. And that's frustrating and doesn't help. Oh. Another problem from our lecture. This is a computer science lecture, so our problems are always just code. Because our students usually think, sounds stupid, but they think in code. They like code better than mathematical formulas or written text. So this is a code, Python code. It includes PyCrypto. You can install it with pip PyCrypto. Public key RSA. Then it reads the flag from a file. Generates an RSA key with 2048 bits. Modulus, that's a common size. That's what most people use nowadays. It's a common practice. An exponent, which is also right. Then it decrypts the flag, and the student just gets the encrypted flag and a modulus. These are both public values in a cryptographic system. And now the student has to recover the flag, the plaintext. And this is an actual Python library. There's nothing tampered with it. Yeah. So the student has to figure out how to break it, which is actually quite easy in this case. If you're interested how to decrypt this, you can just try solving the challenge. Or ask me later if you're really interested. But I would, of course, strongly encourage to... Does that mean I have 10 more minutes? Oh, okay. Then I'm actually early. So we have a lot of time for questions. I don't know if that's good or bad for me. Okay. Yeah. So, if you're dealing with nerds, if you're dealing with computer science people, I would always say just give them a code snippet or give them actual code, give them an application, and then they have to figure it out. And don't write an explanatory text what this code does, because a lot of people, okay, they have heard RSA before, but they don't know what it does exactly. And you shouldn't tell them in this. I mean, if you do it in the lecture part, it's fine, but during the PBL phase, well, they have to go to Wikipedia. Wikipedia has a very good article about what RSA does. It even has links to a paper by Bonnet, which states common security flaws in the RSA system. Well, they have to learn to find that kind of stuff, read that kind of stuff, understand that kind of stuff. Yeah. So, I rushed over it a bit because I had a lot of slides, but now we have actually time for questions. Last slide. Tips for teaching hacking in your local hackerspace or at university or whatever. By the way, there's a lot of companies, a lot of universities that are looking for people in the applied infosec region right now. Because in information security, there's a lot of people that also do compliance and that kind of stuff, which is fine, but knowledge is sparse right now for the hacker's perspective, let's say. So if you apply these kinds of CTFs for a bit, you will most likely find a place where you can teach or a place where you can work or do both, like me. Yeah, so stick to PBL, that's my advice. We had a very challenging course. We essentially threw everything we had at our students, almost, and they managed really well. They said they invested in our course a lot more than in all other courses. It was more like our course was half of their time that semester, but that also shows because we have a scoreboard in our course, and you need to reach a threshold to pass the week. Essentially, we're playing a CTF every week, and the threshold is not that high, but you can reach a lot more points if you want to, if you're interested in the tasks. And the workload is not so high if you just want to pass. But our students really invested a lot of time, and a lot of them had maximum points every week, which is awesome because the stuff was pretty hard sometimes. Yeah. Do not underestimate your students. I kind of said that already. Some professors at our university were like, okay, I need to make my course easier because we have a dropout rate of 50%. And our course was really hard, and we also had a dropout rate of 50%. So I think it's more likely for you to underestimate your students than to overestimate them. So make the stuff tough. Make it hard. They'll manage. If they're interested, they'll figure out the stuff. You'll be surprised how fast, especially young people, but we also had older people in our course, because it got a little bit popular and then people from companies started coming as well. You would be surprised how fast they pick up if they are really interested and motivated. Yeah. Classical teaching and PBL go together very well. So if you already have a lecture on IT security, you don't have to change it. You don't have to replace it. I would just encourage you to do the practical part with PBL. Right now we're investigating if this also works for software engineering lectures and that kind of stuff, but I've seen it work in multiple semesters very well in this hacking sphere. Last point, very important, enjoy yourself. Your students have to see that you're enjoying giving the lecture, that you're interested in the topic, and yeah, don't take yourself too seriously, and it's important for you, and if you like it, your lecture will be better. Excuse me? Keep healthy? Okay. Yeah, that as well. Yeah, by the way, we opened a lab for the students to do lab exercises, and at some nights I went home at 2 o'clock and they stayed at night. And I stayed, and then somewhat during breakfast time they went home. Okay, so thank you very much. I hope I taught you something. I know it was not very technical. Usually technicians tend to get bored when a lecture is not technical, but yeah, I encourage you to teach hacking or to learn hacking, because it's a lot of fun. You meet great people, and if you have questions or feedback, I know there's a feedback form on the website, you can do that. But you can also write me directly, and if you say the lecture sucked, that's also fine. It's feedback. That's another thing I learned from the lecture. Feedback is very valuable. Write me at itsec.rocks. Oh, I didn't say that. I'm a trainer at itsec.rocks. We do trainings for defense stuff. Yeah, so now I'm open for questions, and we
have 5 minutes for questions.
One thing. You said to avoid guessing. Could you give us an example of guessing? Because I didn't quite understand that.
Yes. So there's a big CTF in Germany called the Cybersecurity Rumble, which was created by a company. We're gonna take it over. We're gonna host it next year, so it's gonna be better. So if you're from Germany, you can participate. We have awesome prizes and great challenges. So they had a challenge in their first issue. Maybe, I don't know if it's a good example. We had an entry field. And of course you can do black box testing on that entry field. And people tried SQL injections, code injections, whatnot, and nothing really worked. And the solution was you add on the PHP file a get parameter debug equals 1, and then it would show you some text off of music. Okay, first of all, you have to guess that there's debug 1. You can test it with tools, but usually during CTFs you don't want to make any tasks where you have to use tools. It's always manual labor, because that way you learn. So if there's a CTF task, for example, SQL injection, it will always be built in a way that SQL map doesn't work, for example. So tools are useless during CTFs, yeah. And then the solution was that you had to input a sequence of la, li, and lu into the text field, and you get the flag. And that's complete bullshit, because there's no service in the world that will ever do that. It was pure guessing. It had nothing to do with information security whatsoever. There was another bad CTF at the guys at Henkel, the washing detergent guys. I didn't know why they had a CTF. No clue. We went there because they had prizes and we won, but it was complete bullshit. And they had a challenge where you download a PDF and it's encrypted. And we're like, okay, let's look at the encryption. Let's see how it's encrypted. Let's see if we can try out like passwords automatically, brute force a little bit. And the solution was the password was hex encoded appended to the PDF. And that's nothing you would ever encounter in real life. It doesn't make sense. You have to guess that the challenge author wanted you to find this, and that's guessing. And if you do guessing and your CTF is on CTF time, you're going to be booed and rated very, very badly.
What?
If anybody has questions, I'm going to be around. Just come to me and ask me or write me an email.